Welcome to a new RKB Bearing Industries educational video, where we deal with the RKB Anti-Wear treatment, one of the special thermochemical treatments that RKB can perform on its products. Thanks to this process, we reduce the metal-to-metal friction between the contact surfaces of the bearing components. In this way, we diminish the risk of premature bearing failure and extend bearing service life. The RKB Anti-Wear treatment takes place in three distinct phases. First of all, the bearing elements are tempered, iron nitrided, degreased, etched, washed and neutralized. Then, the actual anti-wear treatment is carried out. The bearing parts are preheated and subjected to sulfur electrolysis in vacuum conditions. Finally, the treated parts are once again degreased and washed and subjected to an anti-corrosive treatment. As just said, the anti-wear treatment is preceded by the iron nitriding treatment. In this phase, an electrically charged gas of ions is used to alloy with nitrogen the bearing metallic surfaces under vacuum conditions. In order to generate plasma, a high voltage current is applied between the bearing components, rings and rolling elements, which act as a cathode, and the furnace shell, which acts as an anode. The generation of plasma takes place inside the furnace chamber in a vacuum nitrogen-added atmosphere. In this way, the iron ions from the bearing component surfaces, after luminescent discharge, combine with nitrogen in plasma, forming iron nitride. Iron nitride is absorbed as a uniform 20 to 30 micrometers thickness layer in the contact surfaces of bearing components. The function principle of the RKB anti-wear treatment is based on sulfur electrolysis accelerated by an electric field under vacuum conditions. The thermochemical process takes place in the same furnace where the iron nitride treatment came about. The temperature inside the chamber is kept at a constant value of 180 centigrades. In this process, sulfur in gas state is added into the furnace chamber. As a result, the sulfur ions diffuse into the iron-nitrogen ions matrix, forming with the iron ions the iron sulfide. The resulting iron sulfide layer has a uniform thickness of 3 to 6 micrometers. Iron sulfide is a solid lubricant with a hexagonal structure and lubricating properties similar to molybdenum disulfide. Iron sulfide has high plastic fluid characteristics and, being concentrated in the bearing material surface, increases the contact area between the rolling elements and raceways and reduces the contact pressure and the coefficient of friction. The iron sulfide layer, formed in the contact surfaces of raceways and rolling elements, presents as a porous and loose substance that can contain more lubricating oil. It ensures the presence of a lubricating film between rolling elements and raceways, thereby limiting friction wear between contact surfaces. Even if the hydrodynamic oil film doesn't form, due to excessive load or high acceleration and deceleration, the bearings with the RKB anti-wear treatment can correctly function in dry lubricating mode without any abrasive wear, thanks to the self-lubricating layer of iron sulfide. On the contrary, in case of bearings without anti-wear treatment, during excessive load or high acceleration and deceleration, the hydrodynamic oil film doesn't form and metal-to-metal friction occurs. Thus, the resulting abrasive wear will speed up the time of bearing total failure. The benefits offered by the RKB anti-wear treatment to our bearings are related to improved roughness, reduced coefficient of friction, high wear resistance, high fatigue strength, and unchanged dimensions, form, hardness, and metallurgical structure of the material. In order to verify the quality of our bearings treated with the RKB anti-wear technology, we performed a counter-fatigue life test. The evaluation was conducted using a ball-on washer test life prediction tester with a maximum contact stress of 3,580 megapascals and 1,980 revolutions per minute. Out of the 40 balls made of SAE 52100 steel selected for the trial, only 20 of them were treated with the RKB anti-wear process. Firstly, we tested 20 balls, 10 with the RKB anti-wear treatment and 10 without, under normal oil lubrication conditions. Secondly, the remaining 20 balls, 10 with the RKB anti-wear treatment and 10 without, were evaluated under non-lubrication or dry friction conditions. These pictures represent the formation stages of the wear indentations on the treated and untreated ball surfaces under normal oil lubrication and dry friction conditions during the counter-fatigue life test performed in our laboratories. The results were as expected. In the first case, where the test was conducted under normal oil lubrication conditions, the balls treated with the RKB Anti-Wear technology showed a rating life 4.43 times longer compared to that of the untreated balls. Also in the second case, in which the test was done under dry friction conditions, which means without oil lubrication, the balls treated with the RKB Anti-Wear technology had a better behavior than the balls without anti-wear treatment. More precisely, in comparison with the untreated steel balls, the rating life of the anti-wear treated balls was 2.39 times higher. In general, the RKB Group applies the anti-wear surface treatment to cageless bearings subjected to extreme operating conditions and high demands on correct performance. In this way, RKB provides its products with a long-life performance even under harsh conditions. Anyway, based on the good feedback from our customers and the latest innovations from our R&D department, RKB started implementing the anti-wear treatment also on its cage medium and big size rolling bearings, both ball bearings, deep groove and angular contact, and roller bearings, spherical, cylindrical and taper, and washers of axial bearings. In particular, in severe operating conditions, the anti-wear treatment is applied to the rolling elements, while in extreme operating conditions it is also performed on both rings. Summarizing, the RKB anti-wear treatment ensures improved surface quality, improved tribological performance, and bearing life expectancy increased by 3 to 5 times compared to untreated bearings. All these qualities lead to the high reliability and performance of our rolling bearings. The RKB anti-wear treatment is particularly suitable for the bearings used in applications such as wind turbines, power transmission equipments, mines and mineral equipment, earth-moving machines, and more.